Okay, hello everyone. Welcome to another episode of Q&A about business innovation and managing life. And I see a bunch of saved up questions here. Prab asks, do you think LLMs will give everyone something akin to a personal business consultant? I don't know, maybe this is kind of the question of, do the AIs take over? If you ask your AI for advice about what you should do next, then in some sense, the AIs have taken over. More accurately, what's taken over is sort of what an LLM is giving us is kind of, in some sense, what the average of the web says about something. It's pretty good at foraging the web to say, oh, ask this question, it's not been asked before. It requires kind of merging together things that occur disparately across the web. Find the place where these words, not literally this sense, but where these things appear in different places on the web and sort of collect them all together and deliver them to us. So if you say to it, give me ideas about how I might run a party for 11-year-olds who are interested in turtles or something, it has a reasonable chance of picking up sort of the fragments of ideas about that from different places on the web and aggregating something to say. I have to say, in my own experience, and I have used it for a bunch of things, not that specific one, but a bunch of kind of ideation, come up with an idea for things, come up with a name for things, and so on. I usually roll my eyes a bit because a lot of what it says is kind of like, oh yeah, that's kind of the obvious thing to say. And it's not very inspired, but sometimes I haven't thought of the obvious thing. And so it's very useful to see it trot out the obvious thing, so to speak. I think that when it comes to, well, I mean, if it's going to give you lots of conventional wisdom about things, and if you don't know that conventional wisdom, it can be useful. In some cases, the conventional wisdom is pretty flat compared to what's actually needed in a specific case. But so I'm not counting on the sort of companies run by AIs to be that much of a thing. It does make me wonder when it comes to something like project management, and when you say, okay, we're going to get this project done. Here's the definition of the project. Now it's going to be broken into pieces, et cetera, et cetera, et cetera. And people start sending their reports in to an AI. What does that look like? I mean, is it conceivable that that could actually do a pretty good job of aggregating different reports and being able to make statements about how the overall project is going this way? That's the thing that needs to be pushed and so on. Quite possibly, yes, actually. Interesting thing to try. Maybe we should try it. We've got lots of good project managers who could be doing more sophisticated things than chasing after people to do particular, to chase particular issues. Anyway, that's my thoughts on that. Crucial asks, how much efficiency is lost by needing to explain things to a team versus doing a whole design alone? Oh my. Well, I would say that it's complicated because as you get more experience, you often, and more knowledge, you often get better, faster at doing certain kinds of tasks. On the other hand, there are more tasks you can do, and that means that the time slice that you want to allocate to doing that particular task might be lower, and there might be other people who could do that task kind of almost as well. Maybe it'll take them 3 times longer than it would take you, but they'll get it done. And if they do it and you don't have to do it, then it takes 0 amount of your time, except for defining what has to be done, as opposed to taking, some of your time. So, that's sort of the reason to delegate. I would say that when you're working with a team of people, if you have a good team, things are potentially gained by having input from different people who have different, come up with different ideas. They have different backgrounds, they have different expertise, et cetera, et cetera, et cetera. It is non-trivial to run that team so that you get sort of more out of it rather than less out of it. The other thing that can happen is, oh, everybody has an opinion, and there are, 10 different opinions, and then in the end, it's like, well, nobody really knows what to do, and we just do some mushy thing in the middle that doesn't really make much sense. But if you are leading that team and you can ask, so-and-so knows about this, you say, hey, what do you think about that? And you're extracting from people, you're plugging people into the things that they can really contribute to, then I think it can be more productive working with a team than just doing things yourself. I mean, I would say that for me, I alternate, and sometimes I get a bit frustrated not doing things myself because I think it's just more efficient. Why don't I just do this myself? As I say, the main downside to that is, well, then you'd have to take the time to do it yourself. And, it could be something where, well, I'd prefer to take those 3 hours and be able to do something else that might be ultimately more productive, and to delegate the thing that would otherwise take me 3 hours. Maybe it'll take somebody else 9 hours to do it, but then it takes me none of those 3 hours to do it. Let's see, Paula is asking, with school ending for the year, what are some ways to continue teaching kids over the summer? Did your summer schedule ever change when your kids would get out of school for the summer? Oh boy, well, I think I think that one thing, education is unlike is a personal kind of thing. Different people learn things well in different ways. I myself personally always used to spend whatever time I could when I was a kid doing projects that were all kinds of crazy things about assembling information about physics and figuring out things about particle physics and so on, all kinds of weird stuff. My own kids have done all sorts of projects some of long-term interest when over summers and so on. I think that if kids are sort of motivated enough and have the ability to execute, sort of doing self-directed projects is a wonderful thing. I think that the more sort of self-directed, invent what you want to do and then do it, it's very satisfying, it's very confidence building, it's a wonderful thing to do. I think that there are, in modern America, for example, a huge number of different sort of things one can send one's kids off to do in the summer. And and some of them, whether it's the summer camp for math, or whether it's the it's the summer camp for music or canoeing or whatever else. These are things that, I think that there's lots of programmed activities like that, which are things that, well, among other things, they're often different kinds of activities from the things that people learn in school. I mean, it's worth remembering that of all the things you might learn about, the ones for which there are school subjects are a small fraction. I mean, a good exercise is, look at a big, printed encyclopedia, for example, and just say which volumes, which major categories of what's talked about there are actually things that show up in lessons in schools. And it's a, not a tiny fraction, but it's not a huge fraction either. And so I think there are plenty of things that one can do sort of in the out of school type setting that are really sort of things worth learning, so to speak. It's certainly not the case that everything worth learning is covered in school subjects. I would say that in my own efforts, we have I think it was renamed this year, but it's always been called our summer camp for high school students. And we also have one for middle schoolers. I think it got renamed Summer Research Experience or some such other thing. But in any case, it's kind of following this, it's a 2-week thing for the high school kids. It's kind of following this idea of sort of invent a project, do a project, and in that case, using our technology. I think the as I say, one of the sort of dividing challenges is our kids going to just say, I want to do this project, and they're just going to go off and do it. And perhaps you have to provide some sort of something to help them do that, but they're just going to go off and do it. And the other is it's a programmed activity where you find them, the summer camp that has, the activity that they want. But it depends a bit on the age of kids, I suppose. Yeah. Let's see. Question from Holsky. What do you think about machine learning libraries versus books? Do you think there's a current infrastructure out there for people to make libraries and sell them to users? It's interesting to think about people buying machine learning libraries for their AI instead of books for their engineers. So if you're talking about training data for AIs, providing training for AIs, I'm not sure. It's a good question. I mean, it's a question that's of some current interest to us. We have created a bunch of training sets that are related particularly to the translation from natural language to orphan language, and training AIs on that. We also can generate a lot of kind of computational training data, which I don't think is particularly useful, because I think when it comes to, here's the solution to this polynomial, here's the solution to this polynomial, and so on, you're much better off using algorithms and computation to solve any polynomial than you are feeding a machine learning system 5 million random polynomials that you happen to pick up. It's just going to get the 5 millionth polynomial wrong. It's not a very useful thing to feed to a neural net, for example. It's not what neural nets do well. Neural nets do well this kind of shallow, broad type of thing. When it comes to actual sort of computation and many-step kind of computation, just not something they do particularly well. I think that there may be an ecosystem of training data. My guess is that the places where there's significant training data, there'll be really a lot of it. And that means various social media platforms, various kinds of things like this, where there will be an argument, and it's already brewing, for whether these sort of kind of maintainers of the social media platform are really the ones who should be charging the AIs to use that. Arguably the original end users were the ones who contributed those things to the social media platform. And it's a question of sort of who should be benefiting. And my guess is what will actually happen is that sort of the web, which has been set up as this very kind of publicly accessible and public kind of thing, it packaged up, which it already is to some extent, will sort of just be the kind of common base training data used by everybody, and nobody will really make much of a claim to it, because any individual's claim is such a small drop in that large bucket of what's out there on the web that it just won't. And for an AI, it's like, well, I could use this incredibly wonderful training data that's over here, or I could use 6 more pieces over here that aren't quite as good, but together they will sort of aggregate into something more or less equivalent. I am skeptical that anything but extremely large buckets of training data will end up being of particularly high value. I think there may be some specialized cases. The particular case that we happen to have a lot of natural language to orphan language, that is valuable, at least if you're trying to do that task. But generally, I would say that I'm not expecting that that's going to be a big world out there. I think also, there's the question of prompts, and will people sell prompts like they sell programs? And I think the answer is a little bit yes, but I think much more so the tooling around how you use an LLM for different purposes and how the LLM calls out to other tools and how it interacts with things, more so than the kind of expository writing of individual prompts. I think, again, okay, so it's worth breaking down several different things, because in typical training of an LLM, there's kind of the big bucket of stuff that comes from the web. Then there are various kinds of, here are essays that are really good, you should pay attention to these ones. Then there are reinforcement learning, human feedback type things where you're saying where the LLM produces something and then you have humans kind of comment on that. Those different ones of here are samples of what you want to actually produce, and here's the interactive thing of the rating of the LLM, those will be much more valuable because those are much more specialized and much more sort of pointedly applicable, and you can get quite high value for comparatively small amounts of data. So my guess is those will be of importance. I think it is exactly how those will sort of be developed and to what extent there will need to be specialized ones developed and to what extent sort of the general ones that sort of cover general linguistics and so on will be sufficient. I'm not sure yet. Des says, what are some simple mathematical tricks and shortcuts that will be good for kids to learn that might make a useful blog post? Things like for powers of 10, the little number of how many zeros come after the one and so on. You know, I did start a few years ago writing a kind of introduction to math for people in general. And I did realize that in the modern world, with both computers as practical tools and kind of the idea of computation as an ambient feature of our civilization, so to speak, there's very different kind of ways into math than one had from something like, you know, the 1800s and so on, or even earlier than that, when the kind of current round of essentially math organization and math textbooks got produced. I mean, I realized I started writing something which maybe I should put out on the web and have people tell me I should either go on with it or not. But I got a few chapters into it and then something else came up. It was very easy to write. I just didn't have a chance to go on with it. But, you know, the very first chapter was about numbers, and it was about why do numbers even exist? I mean, numbers are the thing that sort of launched mathematics, but the idea of abstracting to numbers is not an obvious idea. You know, if you own a bunch of dogs, each one you probably give it a name. The fact that you own 5 dogs where it's abstractly 5 and you can compare it with the abstract number of dogs somebody else owns is not an obvious thing. It's a thing where you have to kind of have that idea of abstracting to the pure number of dogs as opposed to some other attribute, like there are, you know, I have dogs with this name and that name and so on. And so, you know, my first chapter was about kind of this idea of numbers, and then how do you represent numbers? You know, you can represent them as people did, you know, tens of thousands of years ago on sort of tally sticks, where you just like you mark you make a mark for every number, and you're representing things just in unary, so to speak. And then you have the idea of sort of aggregating things together and making positional notation and so on. Anyway, I think it's sort of interesting, the objective of learning sort of mathematical kinds of thinking. Mathematical thinking is an example of abstract thinking. It's an example of going beyond the specifics of words and having something where you can have an abstract structure that you can reason in terms of. I happen to think computation is a more general and broader such, well, it's not a question of thinking, it's obviously the case, that it's a much broader kind of domain of abstraction than mathematics alone. But it's interesting to try and understand sort of how do you do any kind of abstraction and think in terms of that abstraction. That's, in my view, more useful than sort of, oh, you know, every number that's divisible by 3 has its digits, you know, also some of its digits also divisible by 3 type thing, or whatever the result is. I think that's right. I have to actually think about that a bit to know whether that's right, because you can tell I haven't used it very often. But it's, you know, these things where, look, you could just ask a computer and it would just tell you the answer, don't seem so useful to teach people. The thing that's useful is kind of this idea of abstraction. How do you turn some actual thing in the world to something abstract so you can build sort of a tower of reasoning on top of it? In mathematics, there's both a lot of kind of cultural history of the kinds of things that are known in mathematics. What kinds of things can you work out with math? You know, does math tell you what the shape of an oak leaf is? No, the answer is no. It doesn't have a very good characterization of that. Does math tell you something about how, I don't know, one shape will roll on another shape? Yes, it does. It's pretty good at that. You know, there are these kinds of things where there are things that math can tell you, things that math can't tell you. Understanding that, understanding something about the cultural history of mathematics and the sense of what kinds of things have been studied. You know, Complex numbers got invented at some point. They're an interesting idea. Things sort of abstract algebra got invented. It's an interesting idea. And then the other type of thing is sort of thinking about things in an organized mathematical way. One of the things that mathematics does, and it's true of other kinds of abstract thinking as well, is this notion of don't just randomly come up with thoughts, but organize your thoughts in some way. And I suppose a quintessential example of that is somebody hands you a cube and says, label the corners of the cube. Okay, well, you could just say, well, that one, I'm going to call that one Bob and that one Bill, or I'm going to number it 1, 2, 3, and just sort of turning the cube over, and I'm trying to figure out, well, I haven't used up that number yet, so let me use that for that corner. But the fact is, there are systematic ways that you could number the corners of a cube. And, you know, mathematics suggests to you sort of ways to think about that, whether it's with triples of numbers based on the coordinate positions, or whether it's with some kind of sort of curve, unicursal curve, where you're walking from one thing to another, or whatever. But the point is that mathematics, the type of thing that's worth learning from mathematics is the way of thinking systematically about things, and also this way of kind of abstracting from the actual, so to speak. And I kind of think those are the things that are really, really worth teaching. Now, to get to the point where you can even discuss those things, there's a bunch of facts you have to know. It's useful to have a certain, when it comes to calculation, it's useful, you've got to have intuition for how the calculation both could be done and the kinds of results the calculation gives. I think that's more important than the details of going through the individual steps of the calculation. Having said that, it's very useful to learn how to be precise about something, and whether that's being precise about how to do things with writing a program or something like this, whether it's with following the minus signs in a math calculation. It's interesting. You know, I did an experiment last weekend. We now have this kind of way of writing Wolfram language code using natural language, using LLMs. We already had some degree of natural language code creation capability a dozen years ago, actually, when we first introduced Wolfram Alpha. But now with LLMs, it's much richer. And so I was trying with some kids, actually, to see if we could write some programs. And what was interesting was the first way you think about writing the program, it's kind of sloppy. You describe it sloppily. The LLM does the wrong thing. But then you have this exercise of, can I actually say what I mean? It's really an exposition exercise because it's actually in English. It's not even in computational language and so on. And then you kind of try and home in. It was interesting to see, you know, kids and so on try and sort of get more precise about how they stated what they wanted. And that's an exercise that's really useful to learn how to do that, to be more precise about what you say when you say what you want. In that particular case, what we found is, you know, it generates Wolfram language code. Sometimes it's really easier in the end just to look at the Wolfram language code. It's pretty good Wolfram language code usually. It's just look at it and see, oh, those things are in the wrong order. That's why the thing that's coming out is not looking right. Let's just put them in the right order and you're done. And it's no longer worth kind of poking at the LLM and saying, hey, you know, can you rearrange this and rearrange that? And then it's going to get it wrong again. It's going to get something different wrong. No, you can just go edit the computational language, because that's as good a representation as anything. That's a very clear exposition of what you're talking about. But the exercise of talking to an LLM and explaining yourself clearly, it's a really interesting exercise. And I think it's one where I really like these kind of exercises for kids, for example, where it's sort of a self-answering question. That is, instead of you do a bunch of work and then a teacher tells you, oh, that's the wrong answer, and you have no idea. You just have to believe the teacher did it right and so on. It's much better when you have something where you can plainly see that didn't work out correctly. You know, you write a little program and the program just does completely the wrong thing. Well, you can immediately tell yourself that was wrong, I need to fix that, rather than waiting for some teacher to tell you, no, that program was wrong, go fix it. And so these things where you're communicating with an LLM and it's like you're trying to write some expositional thing, and normally you'd hand in your exposition and some teacher would give you a grade on it. In this case, it's like, I'm trying to explain this to the LLM and I can plainly see the LLM doesn't understand. I better try and make my exposition, you know, tune it up and make it better. Let's see. Gosh. Well, there's a question here from Josh. If you created an AI emulator of yourself, what will be the first 3 rules of its conduct be? And another one here, if you could prompt engineer an assistant bot for yourself, what would be the most important rules you'd tell it to follow? Okay, those are related, but not the same. Let's see. Maybe they're related. Maybe they're more closely related than I might first think. I think in terms of the way I like to approach the world, it's kind of like actually understand things, actually think about things. Don't assume that just because that's the way it's always been done or the way other people do it, you should always do it that way. So I suppose for the bot, I would say, although this is a tough thing for a bot to really execute at this point, is like, don't do stuff unless you really understand it. That's a tough thing for a bot to execute at this time. You know, I think in terms of kind of a bot that's acting on my behalf, so to speak, I don't know. It's you know, there are lots of, I suppose, principles of integrity that I like to follow as a person, and which I would hope my avatar bot would be gotten to follow as well. But it's an interesting question. I mean, look, I've been thinking quite a bit about kind of the whole question of, I don't know what one should call it. I mean, I sometimes call it AI governance. I'm not sure that's really the right thing to describe it as, but it's kind of getting the AIs to generally do the right thing. And, you know, I've been thinking quite a bit recently about this, partly because I think it's a really important thing to try to figure out, and partly because it feels like there's not as much intellectual thinking going into that question as there should be, given how important it is. And so I've been trying to formulate sort of what are kind of rules of conduct, you might say, or sort of constitutional elements or whatever for AIs. And I sort of my first step there, other than kind of looking at what everything else has said along these lines, whether it's science fiction or religions or self-help books or whatever, these are all sort of sources for, or for that matter, constitutions of countries and so on. These are all kind of sources for how things should be, so to speak, or how one should act. And I think I've been sort of disappointed by the extent to which many of those things seem rather thin and rather platitudinous. I mean, and not very prescriptive, so to speak. And I've been kind of, and also to some extent, you know, many of those things don't apply terribly well to AIs. I mean, do unto others as you would like others to do unto you is a fine thing when there's sort of a human in the loop, and the human has all those attributes of uniqueness of humanity and you know, caring about mortality and all these kinds of things. But when you take those out of the picture and you say, you know, the AI should do unto others as it would like others to do to it, that's a very funky idea, because there isn't, in fact, this same, and now we're getting into things I have not thought through properly, but this whole question of sort of the equivalence between sort of the humans, the AIs, when do the AIs start having sort of human-like sort of rights and responsibilities and so on, and how does that relate, and et cetera, et cetera, et cetera. It's all a bit muddled, at least in my mind, and I think it's a very important thing to resolve. I mean, one of my first sort of efforts was coming up with sort of the in a sense, ethical conundrums where you can ask, well, what should the AI do in this case? And often the answer will be, well, it depends what the humans want it to do. It could be A or it could be B. Both are viable. It's just a question of choice on the part of humans. You know, one of the things I realized very recently is, you know, I'm used to doing things related to science. And one of the kind of fundamental principles of science is that it's possible to separate out a subsystem of the world that behaves in a fairly simple way and produce a narrative for that subsystem without worrying about what happens in all of the rest of the world. I actually think that the concept that science can be done that way, this is maybe getting a little philosophical, is closely related to the fact that we believe we have the conceit that we have free will. That is, that we can choose to do one experiment and not another experiment. If every experiment we did was always predetermined, then there will be no, we just have the universe is doing all the experiments it's doing, and we wouldn't have the possibility to say, no, 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 I want to do this experiment that's a broken off subsystem type experiment, independent of this whole flow of things that are going on in the world. So this idea that it is possible to break off a subsystem of the world, to say, we're going to look at this thing in this closed box, and it's not going to be influenced by anything else in the world, and we're going to study, we're going to get a sort of scientific narrative for how this thing behaves, that is possible is I think related to the sort of conceit of free will and so on, but that's also a common experience in science as we do it. Okay, why am I bringing this up? Well, because I think one realizes that when it comes to ethics, that really can't be done. You know, in a typical, oh, let's pick between and some kind of trolley problem thing, you know, the 5 turtles and the 2 ostriches or something. You know, how do we pick which one? Which one we want to run over or whatever. It's that question doesn't really have, despite the way that problem is set up, doesn't really have this sort of independent kind of in a separate box type answer. It depends, you know, the ostrich relates to this whole collection of ostrich eggs and, you know, its whole history and its relationship to human civilization and so on. And the turtles, the same thing. And, you know, might they be, et cetera, et cetera, et cetera, et cetera, et cetera. It's it is no longer, you can't break off these subsystems and sort of close things off. And so that's, I think, one of the reasons why sort of scientific thinking doesn't work so well when it comes to things like ethics. And I think one needs another kind of sort of formalized thinking about those kinds of things. I don't really know quite how that should work. And in a sense, the LLM is a story of, in some sense, a collecting, a formalization, a packaging of kind of a big swath of human knowledge. You know, whereas in science, we've tended to concentrate on these specific sub areas and say, we want a subsystem we can talk about separately. The LLM is just gulping up the whole web with all the random things in it about, you know, turtles and ostriches and a zillion other things. It's gulping that all up and putting it all together into this thing that is the LLM. And so in a sense, it's perhaps, if we say, well, what's the science of the LLM? In a sense, the LLM, there are things we can sort of say scientifically about the LLM, but it's kind of one of these things which are a little bit like the ethics problem, that's kind of encapsulated together sort of everything, and it no longer is possible to sort of have these point statements about it. This is, you know, I'm just starting to think about this stuff, and I have to say, I don't think I've adequately unscrambled it. So hopefully in a little while, I'll have clearer things to say about this type of thing. Let's see. It's a question here from Jake saying, I'm a software engineer with about 8 years of experience, interested in transitioning into AI and machine learning. Find it quite difficult to find careers in the marketplace that don't require 5+ years of experience in AI and machine learning. Any advice on how best to make this transition? You know, one of the things I find most amusing about sort of AI and machine learning and jobs and so on is, you know, when machine learning became a popular thing in the early 2010s, after sort of the sort of breakthroughs that happened in 2012 and so on in deep learning, you started seeing these resumes where people said, you know, 20 years of experience in deep learning or 20 years of experience in machine learning. It's like, what on earth is this? Nobody was doing machine learning in the last 20 years. It was largely a dead field. There was a very tiny number of people. And what it often was people who had been doing things like statistics or other fields that could be rebranded as machine learning. And then, by golly, it's a better brand, so put it on the resume type thing. So I do think that I mean, there's a little bit of that's going on. When people say, I want 5+ years of experience in this area, I'm not sure that when people say they have it, it's really that thing. It's just like people writing, oh, I know how to write code in Python or something because I could write 3 lines. Frustratingly, they often don't say I can write code in mathematical or Wolfram language because they wrote something much bigger, but they thought it was too easy for it to be actual code. So it's they don't put that on their resumes, which is a shame because it would help them get jobs, because people know that's a thing that sort of requires kind of an understanding of kind of computation as a set of principles, which is sort of the ultimately most important thing. Plus, also, it's a useful tool for actually building real things in real organizations. But I would say, when it comes to what does it mean to be a machine learning engineer or an AI engineer, I think that you can break that down into a number of pieces. There's an awful lot of what has to happen in AI, machine learning, and so on, which is really traditional software engineering. It's moving data from here to there. Then, okay, dirty secret of machine learning is a large part of it is dealing with the dirtiness of data. Oh, I'm going to train this thing on this data, but the data comes from these different places and the data has all kinds of errors in it, and it's all very messy. And there's a big chunk of kind of the actual activity of doing machine learning that's cleaning the data set. And that's something which, well, actually our technology stack happens to be really good at that. It's something for which that's sort of a general skill of doing data curation, data cleaning, and so on, that, well, it's a skill that is a problem-solving kind of skill. When you look at software engineering, there tend to be different kind of components to that. There's I'm just going to take a specification of an app and I'm going to write something that puts up the sliders and the windows and all that kind of thing according to that specification. Honestly, that kind of software engineering should barely exist. I've spent decades trying to automate away those kinds of, once you can describe it, how much work do you have to do to actually get the thing written? And that's something which LLMs, again, are now helping a lot with. Once you can describe it, one can automate getting it written, so to speak. And that type of software engineering, I think, is going to shrink. I think that how do we conceptualize how to make this thing computational, that's super important, rarely taught, and a thing where there's great value to be had. Not everybody who can do kind of the mechanical writing of software is in any position to conceptualize kind of how should we think about these things computationally. But that's another piece. Then another kind of component of software engineering, which goes more into the kind of DevOps area and so on, is debugging. That's a big piece, particularly when you come to large distributed systems and many servers and running all kinds of complicated server systems and so on. This something goes wrong. What's going wrong? Can we figure it out? That's an area where there are people who are very good at that, who have very spotty kind of official educational backgrounds and so on. I mean, this is true throughout software engineering, I have to say, that the details of the educational background are not as good an indicator as you might expect of people's effectiveness in doing these things, and it's especially true in DevOps and things like sort of debugging large systems and so on. Debugging is a problem-solving story, and I have to say, I have found what does it take to be good at debugging things? I think it takes knowing a bunch of stuff, like, hey, I've seen something like that before. It takes thinking systematically and not assuming things. It takes, in time, a lot of things I've done along these lines, it takes actually being able to use sort of abstract analytical thinking and actually say, oh, I've got a log file with 100,000 things in it. I'm going to write a piece of Wolfram language code to process this log file to find anomalies in it, rather than, oh, let me look through the first 5 pages and try and see if I notice something. It's a type of skill. Now, when it comes to machine learning and you sort of break down what are the things involved in that, there's a fair amount of traditional schlepping data from here to there, software engineering. There's this data cleaning kind of thing. There's then at some level, there's the core sort of underlying sort of, in a sense, mathematical physics, you could even think of it as, of sort of how do the machine learning systems work? What is the annealing schedule for this? How do you what should you put in the batch normalization layer for this and that and the other? The number of people who really do that at a core level is very small. And there is, I think, in those areas, a lot more lore and tradecraft than there is sort of scientific thinking, although occasionally scientific thinking is really useful. It's a good heuristic. If you look at fields and you say, how many physicists are there in this field? When there's a big gaggle of physicists, that's when the sort of the mathematical thinking and so on stuff has turned out to be useful. And there are some gaggles of physicists in the machine learning area. But I would say that if somebody starts telling you, oh, you don't understand, a conditional distribution of this and that and the other, some very mathematical thing, that's not what most of actual machine learning engineering is associated with. It is useful to understand those things from time to time, but only if you want to go very deep. I mean, it's kind of like saying, if you want to do software engineering, do you need to know how to write a compiler, or do you need to know how to do register optimization for a compiler? Well, the answer is no. That's something that somebody else did, occasionally having the intuition for, if I knew more about memory allocators, I would know that I'm getting horribly fragmented memory in this case, and the allocator isn't being able to merge the blocks or whatever else. And knowing that, having that sort of base, more technical knowledge is helpful to do a practical piece of software engineering. But I wouldn't be too put off by sort of what, you have to learn all this formal mathematical stuff to do machine learning. I don't think that's really true. I mean, I could recommend specific things. I mean, we have these courses about machine learning with Wolfram Language, which I think are pretty good. There's a book written by a person who ran our machine learning group for a while, Etienne Bernard, about introduction to machine learning that I think is quite good and very sort of practical about how to do things. But I would say that in the best way to learn about any of these things is have a little project that you try and do yourself. And I would like to say that our technology stack is really good for being able to, it's a tall tower that's already been built. And so you can do a little project and understand the principles and really have it work in a way that you really can't. You're diving into gobs of, you're writing, thousands of lines of Python code, and you're trying to figure out how to install this or that weird thing. In our technology stack, this has all been automated away. And it's a good thing. And I know in my own experience, I just got exposed actually to something where I needed to use some piece of code that was some Python thing, which you can do and call it from Wolfram Language. But what an incredible mess. I mean, all these random libraries and different things that didn't work on one computer and worked on another computer, and different versions of this and that and the other. It's horrendous. And that's something where, yes, if you are an experienced software engineer, you can kind of hack your way through that jungle. But if you want to learn about sort of the principles of what's going on, it's not really a worthwhile thing to be doing. But in any case, but I would say that the thing to do is to think, what is a project you can do where you can actually get sort of where what the point is, you can define what the point is, and you can kind of work through it and do it. That's probably the best way, in my suspicion, about sort of knowing what it takes to do AI machine learning kinds of things. I do want to emphasize that I think the use case is at this point much more important than the details of the mechanics of the technology. Understanding what you're trying to do and conceptualizing that well, I think that's the really valuable thing. But to get to the point where you can do that, you have to know a certain amount about what's possible, a certain amount about what's been done, etc. I don't think you have to know the kind of mathematical physics details, even though those are quite lovely. Yeah. Let's see. So a question from Fleming here. Is prompt engineering becoming a legitimate field of study at some point, or is it mainly a trend due to current systems? I think prompt engineering, I don't know exactly. My guess is that prompt engineering is mostly going to be expository writing with a few tricks. my guess is that most of those tricks will be encapsulated in tools that can write prompts and so on, rather than it being a thing where you have to know them. But I'm not certain of that. The other question is, to what extent are you doing kind of AI psychology when you write prompts? To what extent are you trying to say, let me kind of think about my way of thinking about how the AI thinks and write a prompt based on that? I don't know to what extent that's going to be useful. So far, I would say that other than some very coarse kind of narratives about how the AI works, I don't think that's been terribly useful. An example, an LLM is writing one token at a time. It's progressively writing tokens. So it doesn't get to plan what it's going to write. It just writes another token looking at what it wrote before. So for example, a trick that you can use is to say, okay, LLM, you've produced an answer. Look at your answer. Is it correct? And the LLM will then have a chance to go look at everything it produced. And then it might say, oh no, whoops, that answer is wrong. Let me correct it. And it starts doing more work. Because it couldn't have, it didn't, as it was producing it, it didn't sort of have the whole picture. But if you tell it, go back and look at the whole picture, that's useful. Another thing is kind of leading it through kind of step by step, rather than saying, do the whole giant thing. You say, well, think through what would be the steps that you would take to get to that end result. Now do the first step, now do the second step, et cetera, et cetera, et cetera. That's another example. Those kinds of things are not really that different from the way one would lead a human through these things. And they're things where when one does, for example, expository writing, it's kind of like you don't just sort of say everything all together. You say it in steps and you build up this set of ideas and then you get to the next thing and so on. So I think I do think, by the way, that there will be some more tricks discovered and so on, but I do think that whatever works now and whatever is the way to explain yourself to an LLM now, it'll change a bit, but I don't think it will change super dramatically. That's my current guess, at least. Let's see. JR asks, what does it take up front for you to fully invest in a potential idea? Must there be a proof of concept done prior with rigorous testing? No. I mean, I guess that for me personally, I, perhaps unreasonably, have developed enough confidence that when I think I really understand something, I'm confident about it, so to speak. So for me, the critical thing in investing in something is, investing in an idea, investing in some project or whatever else, by investing time, putting resources into it, it's, do I really understand this? Now, there might be a question of, if we build it, will people come? That is, if we build it, will anybody care? That's something that's often harder to answer. And there are people who are just, who are impressive at saying, if you do this weird thing, if you make this if you do this weird, I don't know, movie, ad, weird sort of social media product, weird this, that, or the other thing, weird event, whatever else it is. To some people it might be, well, that sounds pretty lame. I can't imagine anybody's going to care. And there are people who are really good at saying, yes, people will care about that. I think in a few restricted areas, I'm okay at doing that. But there are plenty of areas where I know I don't know. And if you say to me, will it become popular to have a social media platform where people, only post sort of what they ate for breakfast every day? Will that become popular? I don't know. Wouldn't have thought so, but who's to say? I think there are, it's, for me, there's some uncertainty sometimes about how the world reacts to something. But the first question is, do I understand the idea itself? And do I think it's possible, can I, for example, one question is, you have a great idea and unfortunately it just can't be built. So, that will happen a bunch around LLMs. People will say, well, let me get my LLM to write code that's going to, do precision engineering of this and that and the other thing. Well, you can say you'll do it, and you can kind of huff and puff, but it's probably not going to work. Or you can say, let me create an LLM which will write really high quality poetry. Not going to work, probably. And there are these things where you can sign up for something that's just not going to work, or it's not going to work with technology that exists at this stage in the development of technology. So for example, a good example where people have done this multiple times over the decades is augmented reality and virtual reality. Is it going to work? Is it going to get to the point where it's compelling enough that anybody cares? And that's been a thing where knowing, if you go into that project and you say, I'm going to spend X amount of money and I'm going to build this amazing system, that's a hardware problem in that particular case. And it might be that there's a light at the end of that tunnel and you can actually build such a system, or it might be that, sorry, in the current state of, whatever it is, battery technology, computer technology, this, that, display technology, whatever, you just can't get there from where we are now. And so that won't work. But I think that's the kind of thing which, for somebody like me, at least, it's like once you've sort of wrapped your arms around the project, you can have a pretty good idea of whether it's, whether it can be executed. Now, there may be some questions about how well is it going to work? Is the LLM really going to be able to do this? Or is it always going to be kind of cruddy at doing that? Those are things that may be hard to answer. And when it comes to those kinds of things, obviously you try and make prototypes and you see how far you can get with that. Sometimes it's difficult. Like with Wolfram Alpha, it was very hard to make a prototype. It was either like it was going to be big enough that it really worked well, or there just wasn't enough there that you could expect to walk up to it and ask a question and have it be useful. So there are some cases, I think LLMs would be another example, where it's very hard to make a prototype. Until you were making the whole thing, you couldn't really tell whether it was going to work. There was no sort of mini system that would let you tell whether it was going to work. The same is often true when it comes to sort of presenting things to the world. When, if you present it to 10 people or something, maybe you get some useful feedback from that, but maybe it's the kind of collective, the way it plays in the world that's really important in the dynamics of how the thing gets absorbed. And that really doesn't, you can't tell that until you actually deploy it in the world and see what happens across sort of the actual groups of people that exist in the world. Let's see. JR says, isn't it inherently unwise to seek out AI help, especially in a corporate setting, as it may lead to leakage of information? Yeah, well, I think, in the current state of things where the main LLMs are running on centralized servers and not particularly partitioned or anything like that, yeah, it's a question. I mean, look, is it unwise to use a search engine because it may lead to leakage of information? Yes, to some extent. I mean, it depends on how much you trust the companies that make search engines and so on. It's in the case of LLMs and AI, if it's something where it says, hey, take all this code I have and try and do something with it. Well, yes, you're uploading it to a server. But I have to say that with software as a service and cloud services and so on in general, the corporate kind of acceptance of the fact that it's going off to somebody's cloud seems to be, in many sectors, remarkably high. Sometimes I'm amazed at the level of sort of trust that people put in cloud providers. And I think it's kind of crazy. And I think that, if you have a company of any decent scale, more than a few hundred people, and it's a technical company, there's a lot of stuff you should be doing yourself in-house and not sort of farming out to software as a service cloud kinds of things. It's really a question of, do you have enough scale that it's worth your while to have, DevOps engineers and things like this to run systems, or if you're below that scale, it doesn't make sense to do that. But above that scale, it's much better and probably cheaper to be doing these things yourself than to be farming them out to somewhere else. At least that's been my point of view. Let's see. Eli is asking, do you find the key to being productive? You must structure your mind in such a way that you tackle problems as projects. What advice would you have for the more sporadic-minded individual? I mean, for me personally, you're right. I am a project-based person, so to speak. I sort of collect what I'm trying to do into a thing of a certain scale that has a kind of beginning, middle, end. And it has kind of a thing that you can deliver, that you can sort of tie in a bow and, and sort of say, this is a finished thing that we can then build on, so to speak. That's been very much the story of what I've tried to do, is to turn sort of ideas, free-floating individual ideas don't usually turn into much for me. They have to be sort of aggregated into a project of a certain scale where you can kind of say at the end of it, this is my project. It's, I can explain it in one sentence. What is this project? Maybe the details of how it gets absorbed and so on is a more complicated story, but you can say, I studied the second law of thermodynamics. I wrote an explainer for ChatGPT or something. These are projects where there's kind of a simple explanation of them. When it comes to the free-floating ideas and so on, it is an interesting and challenging thing. So I know quite a few people who have a lot of many sort of individual free-floating interesting ideas. It's challenging. I mean, sometimes people will sort of write books of aphorisms that contain lots of those free-floating ideas. Occasionally, one of those becomes famous and people really pay a lot of attention to it. Usually, I would say that's not typically the story. And even when you have, aphorism, all these aphorisms, you have to kind of put a wrapper around it that kind of sort of explains roughly what these aphorisms are about. I mean, like a friend of mine in the AI world, no longer alive, but named Marvin Minsky, he was very much of a free-floating ideas kind of guy, at least in the later parts of his life. And, he wrote a book called Society of Mind, which he was originally going to write in verse. And I think various people, including me, talked him out of that. But in any case, it was an idea per page. And it's a book with a bunch of pages, with a bunch of ideas. I don't think he was very happy with the response that he got to that. Now, I have to say, in my own case, for example, one of the things I admit that I have done is that there are projects like my book, A New Kind of Science, or for that matter, Wolf and Language, where within the matrix of such a project, there are a very large number of individual ideas that can all be sort of hooked into that matrix. So, you can have sort of free-floating ideas so long as you have this matrix into which to hook them. And I suppose for Marvin, for example, the matrix that he had was, I'm going to write a book where there's an idea per page. I would say that other people I know, there's a famous thing from the 1960s, actually, that was done, actually also at MIT called, and in fact, Marvin was even involved in that. It was called HackMem. And it was a collection of kind of aphorism type statements about, oh, this is a way to compute pi. Oh, did you know that you can do this with a computer memory? You can organize it this way. Each one is sort of a paragraph talking about something. Now, sometimes those things, together, they make a package that is compelling. Now, another example, Benoit Mandelbrot, creator of fractals, spent a lot of his career studying all sorts of different systems with sort of general applied mathematics techniques. He often got into power laws and studied their consequences and so on. Then when he came to sort of try and produce a book, actually partly through a book editor, he kind of ended up with this sort of packaging of, it's all about power laws, it's all about fractals, and by the way, we'll make pictures of them. But if you looked at the individual things that went into that, they were quite disparate. They were quite sort of a paper about, frequency of words and language, a paper about fluid turbulence, all these different things that were all being done in a kind of different ways. But then he managed to find a wrapper into which to put all these things. So that's, the post-wrapping of kind of more free-floating ideas, I suppose, is a possible thing. I mean, it takes sort of a integrative thinking about all these ideas you've had. How do they all fit together? What is the bigger picture? Even if the ideas were pursued individually, maybe in aggregate, 50 of them, you can identify, well, they're all in this particular arc of concepts. And then even if the best you can do is put up a website, put out a book or something, which is kind of these individual ideas, putting that wrapper around it so people can sort of grab onto it and know, oh yes, I'm going to read this because it's about, I don't know, kind of implications of the Rulliad or whatever it is, that everything is sort of related to that, then you might read an individual page that's talking about biological evolution, another page that's talking about linguistics or something, but you kind of know that you kind of know what you're signing up for, and then it potentially is something where it can be absorbed by other people. But I think it's, different people have very different kinds of timescales for the things they do. I mean, I'm always interested, when we're hiring people at the company, for example, it's worth recognizing that there are different kinds of jobs that are good for people with different kinds of attention spans, basically. If you have a 15-minute attention span, but you can do amazing things in 15 minutes, technical support is a terrific area, because it's a place where somebody has a question, if you can answer it in 15 minutes, everybody loves it. On the other hand, if you're doing sort of long-term R&D, where it's a 2-year project every time, the 15-minute attention span is not going to work out. And if you feed the person with the 2-year project optimization, the 15-minute thing, they will have spent 2 days trying to define the problem before they even get started on it, and nobody's happy. So it's kind of like different people have different timescales that correspond to different kinds of activities. I think when it comes to sort of intellectual work, and can you make it work to have these kind of sort of more aphoristic ideas? I'm not sure. Academics, I would sometimes say, I see, I'm thinking of one academic in particular who writes kind of a blog where he seems to write it almost every day, where it's kind of like oh, there's an idea. It's a page or two about that idea. Okay, that's the end of that blog. Okay, there's the next day, and now it's a different page. I was actually just telling him he should collect these in a book, and he was like, wasn't sure that made any sense. I don't know. That at least has a chance of sort of having an overall wrapper that makes this make sense. But I would say that academics often find in their academic papers, if you can get to the point where you can churn out a paper, there was a time in my early life, I would say, where I produced a physics paper every 2 weeks. And so, admittedly not for very long, for much of a year, I think, but not longer than that. And they were even not too bad papers. I had kind of a secret weapon at that time, which is I'd started using computers to do mathematical calculations. And that meant that I could do things at a much faster rate just because of that automation than your average sort of physics bear, so to speak. I think that if you can get the academic paper production thing down to enough of a machine that you can produce them quickly, then I do know people who have pretty short attention spans who spin out lots and lots of academic papers. I suppose the other strategy, I don't know whether it works, is to work with other people. I think it might just drive everybody crazy. Because if somebody is coming along saying, I've got a new idea, and somebody else is saying, well, I'm just going to go through and systematically make these ideas work, I think, everybody goes crazy, because the person with a new idea says, wait a minute, you're not paying attention to my new idea, and they get very frustrated. And the person who's trying to make the thing systematically work is saying, what do you mean you've got a new idea? I'm still working on this old one. Let's see. Apparently having issues with this stream, but we'll see what happens with that. Well, I'm not sure. Is this working correctly now? Okay. Well, I think probably we should apparently things are down, so we don't get to interact in real time here. So maybe we should wrap up for today, and we'll save up the questions that have come in here for another time when the internet is actually working again. So, in a time-shifted way, let me say goodbye for now, and hope to see you again in real time another time. Thanks. Bye for now.